Hello. Today we will discuss the devices to connect the internet. So first of all, I have to turn the pointer into a laser mode. So previously we discussed a little bit all about the paths required for communication, and today we discuss some of our hardware component to connect with the internet. So first component we use as a modem, and that is the one of a main component at your local area, which used for a modulation and a demodulation. The second is the router, and the third one is the switches. So I shift towards the router because modem, we discussed the modems earlier in our earlier classes. So routers basically, as it is a networking device, it's used to connect the different networks together. So that is the reason it's called a networking device. For example, if I'm talking about Air University network, so Air University is defining our network, and if Air is communicating with the Bahariya, so that means two different networks are communicating with each other, and so on and so on. That chain is building in longer distances. So that is the one of example we have here. We have three routers available, router A, B and C, and that is a representation of a router, the schematic representation. This one is a schematic representation of a router. So what's happened here, and one more thing I want to add here, routers are intelligent in terms of routing. They know their location. For example, if I want to communicate towards NTU network, so my router, the I service provider router, are intelligent enough. They know where is the NTU is located, what are the geographical location of NTU, and which router is communicating with the NTU. So it's directed traffic towards one of a particular router. So that is the reason it's called an intelligent device. So we have three routers in this example, and each router is creating a routing table for it. For example, if you see 10.1.00, 10.2.00, 3.00, 4.00, so we have four networks available here, and the four networks are joins with the help of three routers. So each router is creating the routing table, and each router containing all the networks available. They make create a record for all the networks, and then we have a distance calculation is coming here. What is the distance calculation? Basically each router is calculating the distance towards nearest towards the all of networks. So for example, if you are sitting at A and looking for a distance of 10.1 and 10.2, so these two networks are directly connecting network with the router A. So that is the reason we have a zero distance or hop count is available in this routing table. And if you are sitting on A and looking for a 10.3 network, so we have a one here, 10.3.1. so it's being a router. If you are sitting on a router A, we have to jump one router B, to reach towards a 10.3 network. And similarly, if you are sitting on A and looking for a 10.4 network, so we have to jump the two routers here, and that is the reason we have a two hop count available here. And this is important criteria for the optimization routing. This is one of a distance table is creating here, and these are the sum of our interfaces. E node is Ethernet 1, S node is serial interface 0, serial interface 0, serial interface 0. It means if you are sitting on the router A and you want to move towards a 10.1 network, so the interface, nearest interface is E naught. And similarly, if you want to go towards these networks, so the interface is used for to carry the traffic is S naught. Towards the this direction. Similarly, router B is again creating the table in the same way, and router C is again creating the table in the same way. Just we have a crosses here, so it means the 10.4 network is down for a router C, so we cannot reach towards the 10.4 network. So that is the reason we have a down is here. And similarly, if you want to reach towards the 10.1 network while sitting on C, so again you have to jump the router B and our router A to reach towards the 10.1 network. So look at this here, 10.1.00 is 2, the hop count, the distance is going to be 2. So that is a distance calculation. Router are used for this type of a distance calculation. So moving further towards the routers, so it's basically carry the data packets. So what are the data packets? So it's just a combination of packets together, and these packets are forwarded towards the one of a targeted network, and this routing is basically is called IP based routing. It means the system A is defining with the help of IP addressing, and router use the IP addresses to reach towards a destination. And that is again one of example here. The host A is available here, connecting with the one of a device, and then this device is connecting with the R1, and you have another network here, and you have another network here. This scenario is here. We create one scenario, and that scenario is that A wants to communicate with the host B. So what's happened here, the router R1 is creating a table. So first of all, the two things are important: the destination address, which is a host B if you are here on that particular network, and the next hop address. Next hop is the next router address available. So if you are sitting on this network, so next hop address is R1. And similarly, if a packet reaches towards the R1, so the next hop address is R2. So look at this thing, for R1 the destination is still remains same, but the next hop is going to be changed, which is a R2, and destination for R2 destination is going to be same, but next hop is not calculated because the host B is connecting with the R2. So this is again one way of creating a communication link between the two clients working with the different types of routers again. And this is a first time it's create these type of entry, and when a second time A wants to communicate B, so every routers know where is A, where is B, so it's not route the packet towards all the network, is not forwarding the packet towards all the networking, and again it's not broadcasting the packet towards the all the network, it's just send the packet towards the targeted path. And what is the targeted path? If A wants to communicate with the B, so the path is that A sends the packet towards the R1, R1 sends towards the R2, and R2 sends towards the host B. So that is created here. The route is again created here. Okay, we have a destination which remains the same, but the route is calculated earlier here by the R1, and this is due to the first time communication taking place between system A and system B, or between the clients. So that is a routing table, and this is about the routers. So wait a minute. Okay, then we discuss a little bit about the difference between modems and the router. There is one of a misunderstanding available here in the market, that they both are the same devices, but that is not in that way. They are not the same devices. The modem is just a device used for modulation and demodulation, and the routers are basically the used for forwarding the data packets from a network towards a network. So the router is basically used with a landline connection, and that the thing the router can perform is just a to D and a D to A conversion. And the I'm talking about the modem. And if I move towards the router, so it's used for data forwarding packets between the different networks. So that is our two different things. And if I'm take the connection, router can connect several users at a time. We have a number of users connecting with the router, but with the modem we can connect a limited number at that time, and maybe that limited number is up to 5, up to 15, up to 20, depending on the manufacturer. And if I'm talking about the security point of view, so the routers are not secure, but if I'm talking about the router, so there's a security management system exists between the routers inside the router. So routers are more secure as compared to the modem, but we apply a password security that is a little bit one layer of security on the modem also. So if you are using the wireless or a Wi-Fi, so that is one of our password required for interconnection. But the routers they have one of a physical system installed in the routers for security purposes. So the next device is the switches and the hubs, and that is a very simple device. This is the one of a device we use in a local area network. That is a limited approach switching device. It means we can connect a limited number of users again with the switches, and it's also just broadcast the data towards the remaining ports. For example, in this picture you see a server is available here. It sends the data towards this hub or a switch, and this hub is broadcasting the data towards all of its clients available here. So it's not intelligent device. Look at this thing, it's a non-intelligent device as compared to the routers, because router is send the data packet towards a directed path by calculating the distances, but here it's not sending the data towards a targeted system. It's just broadcast the data towards all of its clients. So it's not a intelligent device, but we use this device in a local area scales. And ISP, we have all know about this thing. This is a access provider. If you have a modem available, we have a system available, we have some of our hardware requirements available for internet connection. So the second thing at a bigger layer comes the ISP. It's provide us a internet access. Depending on the criteria, it may provide us internet access with a fee or without a fee. For example, if you are using one of our service provider PTCL, using the internet services of our PTCL, so you have to pay the sum of money after every month, but some of our government organization working in Pakistan doesn't pay to the PTCL. So that is a free internet, one of example of a free internet. But we as a normal user, we pay the service provider for providing the services, internet services. So we have some examples here. I have a lot of service provider available in Pakistan. The Nayatel is very famous for fiber communication. We have a PTCL, that is a Pakistan Telecommunication Corporation, and then we have a White Tribe, and we have a lot of 4Gs and LTEs service providers are also coming nowadays. And for example, we have a Zong is providing the 4G services, and the other service provider, the Movalink, is also providing this services of a 4G. So we have a lot of service providers available nowadays, and it's a little bit a big picture of what's happening between the ISP and the internet. So the internet first comes towards the ISP, and then ISP distribute the internet depending on the requirement of each users. Again, that is one of our example here how information is travel on the internet. So you as a normal user are producing the digital signal at your home, and you have these digital signals are communicating with your home modem, and the modem is converting the digital signals into an analog signal, and that analog signal is moving towards the nearest DP, and then DP is connecting with the nearest exchange, and exchange is connecting with the internet, and you are browsing one of a page of Google, so that is a Google server. So it's taking the Google is responding you as a registered user, as an authenticated user, and it's apply back in a same way, but it's not maybe adopt the same path, maybe it's not adopt the same path. So it's depending on the different ideas. So that is the one of example here how information is traveled through the internet. So this is all about the hardware device as we discuss. So thank you, and I have to stop it here, and in next class we further discuss the remaining chapter.